Welcome to Science Education Channel. In this video we will discussing about preservation of food and foodborne diseases. 1. General principles of food preservation. 2. Preservation by physical methods. By the temperature TDP, TDT, effect of high temperature on food, factors affecting high temperature application. Canning in detail. By low temperature chilling, freezing, and thawing, factors affecting low temperature, effect of low temperature on food. 3. Preservation by chemical preservatives. Acetates, citric acid, lactic acid, propionates, sorbates, nitrates, salt and sugar. Mode of action, applications. Preservation of food and foodborne diseases. General principles of food preservation. For preservation of foods by the various methods, the following principles are involved. 1. Prevention or delay of microbial decomposition. By keeping out microorganisms, asepsis. B. By removal of microorganisms, by filtration. C. By hindering the growth and activity of microorganisms, e.g., by low temperatures, drying, anaerobic conditions, or chemicals. D. By killing the microorganisms, by heat or radiation. 2. Prevention or delay of self-decomposition of the food. By destruction or inactivation of food enzymes, e.g., by blanching. B. By prevention or delay of purely chemical reactions, preservation of oxidation by means of an antioxidant. 3. Prevention of damage because of insects, animals, mechanical causes, etc. Food preservation techniques, methods of food preservation. Food preservation is defined as the process in which any food may be retained over a period of time without spoilage. The importance of food preservation are as follows. Food preservation increases the shelf life of food, i.e., it can be used for longer periods of time. Food preservation decreases the wastage, spoilage of food. Food preservation increases the food supply and adds variety to the food. It decreases dietary inadequacies. C. Malnutrition. Preservation of food by various methods are based on the following principles. 1. Prevention of self-decomposition, spoilage of food. By destroying or inactivating food enzymes, blanching. B. By preventing chemical reaction, changes, antioxidant application. C. By preventing mechanical damage or damage caused by insects and microorganisms. 2. Prevention of microbial spoilage. By destroying microorganisms naturally present in the food. B. By preventing entry of microorganisms. C. By destroying contaminated microorganisms. D. By preventing growth and activity of microorganism. By applying above principles, various methods applied for food preservation are as follows. Heat treatment, which includes a. High temperature. B. Low temperature. C. Sun drying, dehydration, osmotic pressure treatment. Chemical preservative, food additives, application. IV. Treatment by radiations, cold sterilization. Concept and definition of TDP and TDP in food industries. The key difference between TDP and TDT is that thermal death point, TDP, is the lowest temperature at which all microbes are killed in a 10-minute exposure, while thermal death time, TDI, is the time it takes to kill a specific bacterium at a specific temperature. Heat is one of the most common forms used in microbial control. Dry heat and moist heat are two forms of heat. Moist heat is more effective than dry heat. Heat alters cell membranes and denatures proteins of microorganisms, causing their thermal death. Thermal death point and thermal death time are two parameters related to heat sterilization. Thermal death point is the lowest temperature at which all microbes are killed in a 10-minute exposure. Thermal death time is the length of time needed to kill all microorganisms in a sample at a given temperature. TDP. Thermal death point refers to the lowest temperature that kills a population of a target microorganism within 10 minutes. At this TDP, all microbes are killed in a 10-minute exposure. TDP is one aspect that measures thermal death of microorganisms. TDP is an important measurement when purifying water through boiling. The TDP of E. coli is 80 degrees Celsius. It means, E. coli population in a solution can be killed within 10 minutes at 80 degrees Celsius. The thermal death point varies among different microorganisms. Bacillus subtilis and Clostridium perfringens have high TDPs. Those two bacteria produce heat resistant spores. Therefore, in order to kill their spores within 10 minutes, a high-temperature food microbiology and milk microbiology is required. TDT. Thermal death time refers to the time taken to kill a population of the target microorganism at a specific temperature. Hence, it measures how long it will take to kill all microbes in a sample in a given temperature. It can be easily measured when the microorganisms are in a water-based solution. Generally, the TDT of microorganisms varies because different microorganisms have different temperature tolerance levels. For example, Thermophilus aquaticus is an extremely thermophilic bacterium which is active across a wide range of temperature. It can tolerate extremely high temperatures. In contrast, E. coli is a heat-sensitive bacterium which can tolerate 4 to 45 degrees Celsius and grows best at 37 degrees Celsius. It cannot tolerate high temperatures. Therefore, the thermal death time of E. coli is less than Thermophilus aquaticus. Another example is that the thermal death time of B. subtilis is 20 minutes at 100 degrees Celsius. TDT can be measured using a graph or using a mathematical formula. Thermal death time calculation often uses a measurement called Z-value. Therefore, Z-value is the number of degree of temperature that has to be increased to achieve tenfold reduction in the D-value. D-value is concerned with the time taken to kill a specific number of microorganisms, around 90%, at a constant temperature. TDT was developed for several applications at the beginning. They are food canning, production of cosmetics, producing salmonella-free feeds for animals, e.g. poultry, and pharmaceuticals, etc. Nowadays, TDT is used frequently in the food industry to ensure food safety. Similarities between TDP and TDT. Black circle TDP and TDT are two aspects of measuring thermal death of microorganisms. Black circle. These parameters are often used to describe sterilization procedures that use high heat. TDP and TDT vary among the microorganisms. Difference between TDP and TDT. TDP refers to the lowest temperature needed to kill a microbial population in a liquid culture within 10 minutes. While TDT refers to the time required to kill a microbial population in liquid culture at a given temperature. So, this is the key difference between TDP and TDT. In short, TDP is a measurement of temperature, while TDT is a measurement of time. Preservation by physical methods. 1. Heat treatment methods. High temperature treatment methods. Application of high temperature is one of the most economic and safest method of food preservation. High temperature denatures the microbial proteins, resulting into the inactivation of enzymes and death of microorganism. The application of high temperature to preserve the food depends upon the type of food to be preserved. The effect of high temperature on the food and the number and types of microorganism present in the food. Following two methods of high temperature application are used to preserve the foods. 1. Application of temperature below 100 degrees Celsius, i.e. 60 to 90 degrees Celsius, x. Pasteurization. E. Application of temperature above 100 degrees Celsius, i.e. steam under pressure, example a pressure cooker. B. Canning. I. Application of temperature below 100 degrees Celsius, pasteurization. Pasteurization is the application of temperature below 100 degrees Celsius, usually 60 to 90 degrees Celsius, to destroy the undesirable and pathogenic microorganism without affecting the quality of food. It was first suggested by Louis Pasteur to preserve the wine and beer. Nowadays, it is applied to preserve the milk and milk products, fruit juices, vinegar etc. The temperature applied for pasteurization is in the form of steam, hot water, dry heat or electric heater, and the products are cooled immediately to room temperature. After heating, pasteurization of foods is done by following three methods. A. High temperature short time, HTST, method. In this method, food and food products are pasteurized by applying the temperature above 70 degrees Celsius, for at least 15 seconds. Different food products are pasteurized by applying different temperature. For X milk, 71.7, C, 161, for 15 seconds, ice cream, 82.2 degrees Celsius for 16 to 20 seconds, grape wine, 85 degrees Celsius for 1 minute, grape juice, 77 degrees Celsius for 30 seconds, buttercream, 88 degrees Celsius for 10 seconds. B. Low temperature long time, LTLT, or temperature holding, LTH, method. In this method, the foods are pasteurized by applying the temperature below 70 degrees Celsius for at least 30 minutes. Different food products are pasteurized by applying different temperature. For X milk, 62.8 degrees Celsius, 1451, for 30 minutes, buttercream, 70 degrees Celsius for 30 minutes, grape wine, 68 degrees Celsius for 30 minutes, grape juice, 65 degrees Celsius for 30 minutes. C. Ultra high temperature, UHT, method. This is a recently developed method of pasteurization in which milk and milk products are pasteurized by applying the temperature 135 to 150 degrees Celsius, 275 to 302 inches 1, for 1 to 2 seconds in a continuous flow system. This method is employed to sterilize the milk and milk products such as buttercream, ice cream etc. to increase shelf life, storage period, for about 90 days. However, UHT may alter the nutritive value, flavor and taste of foods after pasteurization. Food materials are immediately cooled to room temperature, then stored in the refrigerator or cold storage. E. Application of temperature above 100 degrees Celsius. Steam under pressure. The temperature above 100 degrees Celsius is achieved by means of a steam under pressure inside the closed chamber. Rise of steam pressure increases the temperature above 100 degrees Celsius. This method kills all types of microorganisms including spores, and the food becomes sterile, i.e. free from microorganism, which can be preserved for longer period of time. There are two methods in which temperature above 100 degrees Celsius, under pressure, is applied to preserve the food. A. Pressure cooker. B. Canning. A pressure cooker. It is one of the commonly used household methods to cook the food. The temperature of about 110 to 120 degrees Celsius for 10 to 15 minutes under pressure kills most of the microorganisms present in the food, and the food becomes free from microorganism which can be preserved for longer period of time. B. Canning. Canning is commercial method of food preservation in which the food is preserved for very long time in sealed container, can, after the application of high temperature, about 121 to 125 degrees Celsius, under steam pressure. Canning was discovered by Nicolas Appert, a Frenchy confectioner, to preserve various food and food product on large scale in army. Therefore it is also known as appetization. The objective of canning is to prevent the spoilage of food and to preserve the much longer period of time. The general process of canning is divided into following steps: 1. Cleaning and peeling. 2. Blanching and filling of the container. 3. Exhausting and sealing of the container. 4. Heat processing. 5. Cooling and marketing. 1. Cleaning and peeling. The various raw food materials such as vegetable, fruits, meat, fish etc. of good quality are selected and cleaned to remove dirt, dust, undesirable parts and microorganisms. Usually food material are subjected to high pressure water SPR for cleaning. Peeling is the removal of surface layer of certain raw food material like fruits, e.g. apples, banana, oranges etc. and certain vegetables, e.g. tomato, potato, radish etc. Remove surface layer along with adhered soil particles, dirt and associated microorganisms. Various methods of peelings employed are steam peeling, flame peeling, mechanical peeling, manual peeling etc. 2. Blanching and filing of the container. After cleaning and peeling, the raw food material is immersed in hot water having temperature 90 to 95 degrees Celsius or exposed to live steam for short time, circa 15 to 30 seconds. This removes adhering dirt, dust etc., which are not removed by cleaning with cold water. It also destroys undesirable microorganisms responsible for food spoilage. Blanching makes the food material as a compact mass which can be filled in the container properly. After blanching, food material is filled into the container, i.e. can or jar, while still hot. Most commonly used container in canning are the steel-coated tin. Nowadays containers made up of aluminum or plastic pouches are used. Containers can be filled mechanically or manually. During filling, care is taken to avoid the trapping of air bubbles within the compact mass of food materials. 3. Exhausting and sealing of the container. Exhausting is the removal of air gas bubbles, if any, from the food material filled in the container. The open-filled containers are passed through an exhaust box or machine in which hot water or steam is used. Exhausting expands the food material, drives out air or gas bubbles and provide an atmosphere of steam in the head space at the top of the can, create vacuum. This excludes oxygen, air, which may react with the food material to cause oxidation and the interior of the container, cause corrosion, and may affect the quality of food. After exhausting, the filled container is carefully sealed immediately to prevent external contamination of the food material. 4. Heat processing. The filled, exhausted and sealed cans are subjected to steam heat treatment under pressure having temperature about 121 to 125 degrees Celsius, for 20 to 30 minutes. This heat treatment destroys most of the microorganisms including spore formers, e.g., Cl botulinum, and the food material becomes sterile. The duration of heat treatment and the temperature applied depends upon reveal factors such as the character and chemical composition of food material, pH of the food material, the types and number microorganism in the food, amount of food material in the containers and the size of the container etc. There is slow penetration of heat in solid food material as compared to liquid foods. A longer heating period is required for larger container than the smaller one. Microorganisms are more easily killed in acidic food, i.e. having pH less than 5.5, such as fruits, fruit juice etc. and needs the heating temperature of about 121 degrees Celsius for 14 minutes, whereas non-acidic foods, i.e. having pH more than 6.5, like beans, peas, meat, fish, poultry etc., needs higher temperature i.e. 125 degrees Celsius for 20 minutes. A long exposure at a relatively low temperature is preferred than a shorter exposure at higher temperature to prevent effect on food material by excessive heat. Heating of the containers can be carried out in the horizontal autoclave, horizontal pressure cooker or batch retort 5, cooling of the container and marketing. After heat processing, the cans are immediately cooled to room temp rapture either in air or in cold water. Immediate cooling prevents undesirable changes in the aroma, flavor and color of the food material. Also rusting of the cans. After cooling, cans are labeled with the date of manufacture, batch numbers, date of expiry etc. and marketed. Low temperature treatment methods. The application of low temperature below 10 degrees Celsius inhibits the metabolic activities and growth of microorganisms and prevents spoilage of food and food products, which can be preserved for some days without spoilage. Two methods are commonly employed to preserve the food material at low temperature. Chilling. Freezing. 1. Chilling. It is the application of temperature just above the freezing point of water, i.e. between 4 to 7 degrees Celsius. The best example of chilling is the commonly used household refrigerator. The common household perishable, easily spoiled, food materials such as vegetables, fruits, eggs, meat, fish etc. are preserved by chilling in the refrigerator for 6 to 7 days. To preserve the food materials on large scale, commercial scale, a cold storage room is built in which 4 to 7 degrees Celsius temperature is maintained throughout. Food and food products can be stored and preserved for long periods of time without spoilage. Certain psychrophilic microorganisms can multiply slowly if the food is chilled for longer period. Therefore, food materials should not be chilled for many days. Freezing. The process of application of temperature below freezing point of water, i.e. between -10 to 35 degrees Celsius, is known as freezing. At freezing temperature, microbial growth is entirely inhibited. Therefore, frozen foods can be preserved for several weeks or months without spoilage, also known as thawing. There are two types of freezing methods. A. Slow freezing. B. Quick freezing. In slow freezing, the food material are kept at 10 to 15 degrees Celsius temperature, whereas in quick freezing at -18 to 35 degrees Celsius temperature. Quick freezing is comparatively advantageous than slow freezing, because quick freezing produces smaller ice crystals which may not damage the food materials. However, slow freezing produces larger ice crystal which rupture and damage the tissues of food and food products. The foods such as vegetables, fruits, meat, fish, poultry etc. can be preserved by freezing. Frozen food does not lose their nutritional value, but the flavor and aroma of fresh food is lost with the length of storage period. Frozen food should be consumed immediately once taken out, because psychrophilic microorganisms began to multiply as soon food is warmed. Sun drying. Dehydration. The removal of water content from the food by drying in the sunlight or by applying heat is known as sun drying or dehydration. The water content, moisture, of the food material is reduced to such an extent, usually less than 10%. So that it do not support the growth of microorganism. Dehydration acts as microbiostasis, prevent growth of microorganism, due to which foods are preserved for very long periods of time without spoilage. Sun drying is a very common method of food preservation. Sun drying is a very common method of food preservation, in which the direct sunlight is used for dehydration. Many cereals, grains, fruits, e.g. dried figs, dried apples, prawns, dried plums, raisins, dried grapes, meat, fish, vegetables etc. are preserved by sun drying. A variety of dehydrated products are available in the market. These includes instant coffee, lemon, citrus juice powder, pre-cooked peas, beans and cereals. The foods dehydrated by heating include papadi, papad, macaroni, bari, potato wafers etc. Dried foods can also be transported easily because of being light in weight and smaller in size. Dehydrated foods are kept in a tight container to prevent from humidity of the atmosphere. Osmotic pressure treatment. Living organisms usually survive under isotonic condition of osmotic pressure, i.e. when the osmotic pressure of the surrounding fluid is in equilibrium with that of the cell's content. If organisms are kept in a fluids with abnormally high osmotic pressure, i.e. hypertonic medium, water will be drawn out of the cells, resulting into plasmolysis, shrinkage of protoplasm of the cells and death of organism. If organisms are placed in a medium of abnormally low osmotic pressure, i.e. hypertonic medium, water will be drawn inside the cell until it swells and rupture the cells, resulting into plasmoptosis and death of organisms. This principle of osmotic pressure is used to preserve the food material. High concentration of salt, sugar and acids are applied for the preservation of various food. Salting is a common method of preserving vegetable and fruits like tamarind, ginger, chili, raw mango, amla etc. Also fish and meat. Sodium chloride, NaL, in a concentration of 20 to 30% is commonly used for salting. High concentration of salt prevents the water being available for bacterial growth and thus food can be preserved for longer time. The high concentration of sugar. About 60 to 70% is used to preserve the foods like jams, jellies, maple syrup, honey, sweet pickle etc. Pickling is the preservation of food by keeping in a strong acidic condition. The use of vinegar, acetic acid, and lemon juice, citric acid, is common in household methods of pickling such as mango pickling, citrus pickling, cabbage pickling etc. Preservation by chemical preservatives, food additives. A preservative is a substance or a chemical that is added to products such as food products, beverages, pharmaceutical drugs, paints, biological samples, cosmetics, wood, and many other products to prevent decomposition by microbial growth or by undesirable chemical changes. In general, preservation is implemented in two modes: chemical and physical. Chemical preservation entails adding chemical compounds to the product. Physical preservation entails processes such as refrigeration or drying. Preservative food additives reduce the risk of foodborne infections, decrease microbial spoilage, and preserve fresh embates and nutritional quality. Some physical techniques for food preservation include dehydration, UVC radiation, freeze drying, and refrigeration. Chemical preservation and physical preservation techniques are sometimes combined. Mode of action of chemical preservatives. The chemical compounds or mixture of chemical compounds specifically added into the food and food products to prevent their spoilage by microorganisms are known as chemical preservatives or food additives. Chemical preservatives inhibit the growth of microorganisms by interfering or disturbing various enzymatic and metabolic reactions. Some chemical preservatives act as antioxidants which prevent the oxidation of food materials. Some neutralize the acidity, alkalinity, and some retard the physicochemical changes occurring in the food during storage. The chemical preservatives added into the food must be ideal and safe for human consumption. Because certain preservatives are toxic and carcinogenic. Therefore, chemical preservatives must be added only after careful testing for their relative safety. Food and Drug Administration has put limitations on the use of some preservatives. They can be used only when proved safe for human and animals. Some important groups and examples of chemical preservatives used for various types of food preservation are given below in the table given below. Acetates. Sodium acetate, anhydrous, is widely used as a shelf life extending agent, PLF control agents. Acetic acid has been said to prevent bacteria cultivation and therefore has been used not only to add sour taste but to preserve food. Sodium acetate is a food additive obtained by neutralization of acetic acid. When used as a food additive, sodium acetate can be indicated by its group name, substance name, or abbreviated name according to the purpose of use. Sodium acetate is a shelf life extending agent, a sanitizer, antioxidant, and preservative are used to maintain the quality of food, as specified in the regulation in regard to food labeling. An antioxidant and preservative are indicated with the application name as preservative, etc. The use of many of these agents is restricted, so they are not available to some food. A shelf life extending agent, indicated only with its name, sodium acetate, functions like these agents, giving slightly moderate effects. It is highly safe and its use is not restricted. Sodium acetate can prevent bacteria cultivation in a wide range of acidic region. It also functions as a buffer as well. When used to add sour taste to food, acetic acid is generally selected. But combination of sodium acetate and acetic acid can make the taste mild. 2. Citric acid. The acidity of citric acid makes it an excellent food and drink preservative. The presence of acid in an environment inhibits the growth of bacteria. So many long-life products contain it. These include preserves, canned goods, meats, savory snacks and sweets. 3. Lactic acid. Lactic acid is a natural preservative found in several foods, including pickled vegetables, yogurt, and baked goods. The bacteria break down sugar to extract energy and produce lactic acid as a byproduct. Lactic acid helps regulate pH levels and prevents the growth of microorganisms, extending shelf life. 4. Propionates. Calcium propionate is a food additive present in many foods, especially baked goods. It acts as a preservative to help extend shelf life by interfering with the growth and reproduction of microorganisms. Though it has its benefits for food manufacturers. You may wonder whether calcium propionate is safe to eat. Calcium propionate is a naturally occurring organic salt formed by a reaction between calcium hydroxide and propionic acid. It's commonly used as a food additive known as E282 to help preserve various food products, including baked goods, breads, pastries, muffins, etc. Dairy products, cheeses, powdered milk, whey, yogurt, etc. Beverages, soft drinks, fruit drinks, etc. Alcoholic drinks, beers, malt beverages, wine, cider, etc. Processed meats, hot dogs, ham, lunch meats, etc. Calcium propionate extends the shelf life of various goods by interfering with the growth and reproduction of molds and other microorganisms. Mold and bacterial growth are a costly issue in the baking industry. As baking provides conditions that are close to ideal for mold growth, calcium propionate has been approved for use by the Food and Drug Administration, FDA, World Health Organization, WHO, and Food and Agriculture Organization of the United Nations, FAO. 5. Sorbates. Potassium sorbate is a chemical additive. It's widely used as a preservative in foods, drinks, and personal care products. It is an odorless and tasteless salt synthetically produced from sorbic acid and potassium hydroxide. Potassium sorbate prolongs the shelf life of foods by stopping the growth of mold, yeast, and fungi. It was discovered in the 1850s by the French, who derived it from berries of the mountain ash tree. Its safety and uses as a preservative have been researched for the last 50 years. The U.S. Food and Drug Administration, FDA, recognizes it as generally safe when used appropriately. Potassium sorbate is a popular preservative because it's effective and doesn't change the qualities of a product, such as taste, smell, or appearance. It's also water-soluble, and it works at room temperature. Potassium sorbate can be added to many food products, such as apple cider, baked goods, canned fruits and vegetables, cheeses, dried meats, dried fruit, ice cream, pickles, soft drinks and juices, wine, yogurt. Potassium sorbate is used as an antimicrobial and preservative in personal care items as well, such as eyeshadow and other cosmetics, shampoos and moisturizers, contact lens solution. Potassium sorbate is also approved for safe use as a preservative in moist cat and dog foods and in other animal feed. Regulatory agencies such as the FDA, the United Nations Food and Agriculture Organization, and the European Food Safety Authority, EFSA, have determined that potassium sorbate is generally regarded as safe, abbreviated as GRA. When you eat potassium sorbate as a food additive, it passes through your system harmlessly as water and carbon dioxide. It does not accumulate in your body. 6. Nitrates. The salts of nitrite and nitrate are commonly used for curing meat and other perishable produce. They are added to food to preserve it and also help hinder the growth of harmful microorganisms. In particular, Clostridium botulinum, the bacterium responsible for life-threatening botulism. The salts of nitrite and nitrate are commonly used for curing meat and other perishable produce. They are added to food to preserve it and also help hinder the growth of harmful microorganisms, in particular Clostridium botulinum, the bacterium responsible for life-threatening botulism. Nitrites, together with nitrates, are also added to meat to keep it red and give flavor, while nitrates are used to prevent certain cheeses from bloating during fermentation. Nitrate is found naturally in vegetables, with the highest concentrations occurring in leafy vegetables like spinach and lettuce. It can also enter the food chain as an environmental contaminant in water. Due to its use in intensive farming methods, livestock production and sewage discharge. In humans, nitrite and nitrate from food are rapidly absorbed by the body and, for the most part, excreted as nitrate. Some of the nitrate absorbed by the body is recirculated through salivary glands and part of it is converted by mouth bacteria into nitrite. Absorbed nitrite can oxidize hemoglobin to make hemoglobin, an excess of which reduces the ability of red blood cells to bind and transport oxygen through the body. Nitrite in food, and nitrate converted to nitrite in the body, may also contribute to the formation of a group of compounds known as nitrosamines, some of which are carcinogenic. The European Commission has asked EFSA to re-evaluate by 2020 all additives authorized before the 20th of January 2009. As part of this program, EFSA has reassessed the safety of sodium and potassium salts of nitrite, A249 to 250, and nitrate, A251 to 252, in two scientific opinions published in June 2017. The current acceptable daily intakes, ADIs, for nitrite, set by the European Commission's former Scientific Committee for Food, SCF, in 1997 and the Joint FAO/WHO Expert Committee on Food Additives, JECFA, in 2002, are 0.06 and 0.07 mg per kilogram of body weight per day, mg per kilogram BWL day, respectively. Bodies set the ADI at 3.7 mg per kilogram BW per day. 7. Salt and sugar. There are several ways in which salt and sugar inhibit microbial growth. The most notable is simple osmosis, or dehydration. This has the effect of drawing available water from within the food to the outside and inserting salt or sugar molecules into the food interior before the rise during industrialization of refrigeration. Artificial preservatives, vacuum sealing and freeze drying. Most foods were cured using a mixture of salt and sugar. Sugar and salt curing is often combined with smoking. Salt and sugar act to increase osmotic pressure, destroying some bacteria and slowing decay, promote the growth of beneficial bacteria, and work together to improve taste. About sugar and salt curing: many foods decay very rapidly after harvesting, especially meats. A combination of salt and sugar reduces the water content of meats, fruits and vegetables, aiding in preservation. In meats, sugar and salt curing is typically accompanied by smoking or some other cooking method. Most preservation methods used since ancient times attempt to reduce water content to between 10 and 50%, a level that reduces decay but maintains palatability. Effects of salt: sodium chloride or table salt is the main ingredient used in the preservation of meats. Salting meat draws water out and tying up the water within, making it unavailable for chemical reactions that cause decay. High concentrations of salt also interfere with the replication of microorganisms such as bacteria. Salt curing frequently uses salts containing nitrates. Nitrates act as antioxidants in preserved foods, preventing decay and spoilage through oxidation and free radical generation. However, high consumption of preserved foods containing nitrates may be linked to a higher risk of cancer. Effects of sugar: just like with salt, some forms of sugar can draw water out of food and tie up water within the food, so it is not available for biochemical reactions. According to the Food and Agriculture Organization, fructose and sucrose are very effective for preserving food while glucose is not. Sugar may also encourage the growth of healthy bacteria that prevent bacteria that will make you sick from growing. High concentrations of sugar also exert osmotic pressure that will draw water out of bacteria, preventing them from growing. Food preservation by radiations. Cold sterilization. Radiations are the energy-yielding electromagnetic waves transmitted through the space or through a material. The energy content of the radiation is inversely related to the wavelength, i.e., the shorter the wavelength, greater the energy content. Based on energy content, wavelength, the radiations are decided into two types. 1. Low-energy radiations, non-ionizing radiations. X. Ultraviolet radiations. 2. High-energy radiations, ionizing radiations. X. X-rays, beta rays and gamma rays. Non-ionizing radiations, e.g. UV, kills the microorganisms by interfering or modifying the nuclear material of the cells, whereas ionizing radiations kills the microorganisms by ionizing cellular molecules. This killing property of radiations is applied to preserve or sterilize the food and food materials. There is no generation of heat during application of radiations for the sterilization and preservation of food items. Therefore, radiation treatment is known as cold sterilization. 1. Food preservation by UV radiations, non-ionizing radiations. The wavelength of UV radiation lies within the range of 220 to 290 nanometers. However, the most germicidal wavelength is 260 nanometers, which is applied for the sterilization and preservation of food and food products for longer period without spoilage. Quartz mercury vapor lamps or low-pressure mercury lamps are used as a source of UV radiation. UV radiation kills the microorganisms by modifying DNA molecule. It forms thymer-dimer within DNA molecule, resulting into the mutation of DNA and ultimately death of microorganisms. UV radiations have very low penetration power. Therefore, applied for the surface sterilization of food and food products, cold storage rooms of food processing plants are equipped with UV lamps, germicidal lamps, to preserve the food materials for longer time. 1. Food preservation by ionizing radiations. Ionizing radiations has a wavelength shorter than that of non-ionizing radiations, i.e. less than fm. They possesses higher amount of energy and greater penetration power. They are called ionizing radiations because due to high energy they cause ionization of cellular molecules, i.e. they drive away electrons and split the molecules into atoms or groups of electrons. For X, water molecules are split into hydroxyl radical, O, and hydrogen ion, H. The hydroxyl radicals so formed are highly reactive and destroy cellular constituents such as proteins, enzymes, DNA etc. Ionizing radiations can also act directly on microbial cell constituents, causing death. In addition to being microbicide, ionizing radiations possesses greater penetrating power and can be used to sterilize the interior of bulk food and food products, packaged foods. Ionizing radiations includes X-rays, gamma rays and beta rays, cathode ray. Out of these, gamma rays are widely used for the sterilization and preservation of food materials. Gamma rays are similar to X-rays but are of short wavelength. They have high energy and greater penetration power. They can penetrate the food materials up to 15 cm thickness. They are widely used for the sterilization and preservation of canned food materials, packaged food materials, perishable foodstuff such as meals, potatoes, meat, fish, beet, pork, chickens. Food packed in plastic bag, paper etc. Radioactive isotopes i.e., cobalt-60, 60Co, or cesium-137, 137 Ce, are used as a source of gamma rays. Gamma radiation is not commonly employed as a routine sterilization of food because it is expensive and dangerous to use. Special precautions are necessary because gamma radiation can cause serious injury to humans.